Okay.
So it's an extreme honor and a huge pleasure for me to introduce Professor Vincent Crawford. And for several reasons, as you see that why we want to celebrate his 75th birthday. Actually, this year is not his 75th birthday. He was born on April 6, 1950, in Springfield, Ohio, USA. And the reason that because this conference only happens in even year, so in any way we cannot have the part on the conference. So we have to do this 1 year in advance. And then you see his contribution and the profound impact of his research on economic theory, matching and auction market design, and then game theory, chip box, and then experiment and behavior economics. And I really want to talk a little bit about his impact on my own research, in particular his 1982 paper, and that has been the great source of inspiration for my own research. So actually, I was not trained as an economist. I was trained as an applied mathematician, but I was very lucky enough to have some course on game theory by Eric Van. And that moment, so I learned the great book by R. Rose. So from that book, I know the name Paul Milgram and R. Rose, and then Roger Madison. And actually, that moment, I already know Eva Talbush was very famous already at that time. And why? I was so much influenced by Vincent's 1982 paper, because so when I was a PhD student, I was studying your paper, and I was very impressed by the beauty of your article, and in particular the condition, the cross substitute condition, and also the process, the George matching process. It was very elegant, and I really like it. And what is later on, so when there's a emerging area in discrete convex analysis, and then so I actually one Japanese mathematician, outstanding mathematician, applied mathematician, Morita, he gave a presentation about his paper with Danilov, Kolchakov, and both Great Russia mathematician. So they have a general condition about the existence of competitive equilibrium in economy with individual goods. And Morita was presenting his paper in Tsukuba, and I was at that moment I was a postdoctoral. So I asked him that, can your condition cover Kőszegi-Crawford's condition, cross substitute condition? He said, unfortunately, we cannot prove anything related to your paper, your model. So later on, I was working with Japanese mathematician Fujishiki, Satoru Fujishiki. So we actually was able to prove that any utility function which satisfies cross substitute condition if and only if it's a natural concave function. So then I realized how profound of your condition related to a profound, actually emerging area of discrete optimization or consortium optimization. And that if you check internet, Google, so discrete convex analysis actually is a parallel to convex analysis, which is so fundamental for economic theory. And the other point, I want to talk a little bit, just a few statements. Vincent's, his contribution is so obvious, but what is also extremely important is for his very crucial role in helping expanding this society. And we are very lucky that because his involvement, so our society was very quickly recognized by UK charity coalition. And so in the sense that the legal status of this society is almost the same as the oldest London society, Royal Society. So thank you for your fundamental contribution to economic theory, game theory experiment, and to our society, also to my person. Yeah, thank you so much.
Thank you, Zaifu, very much for that wonderful introduction. And I didn't realize that the name of my chair at Oxford had helped pave the way for the recognition of the society. One thing I learned today about my own mind and my own work is that it all involves unexpected discreteness. So my motto used to be fortune favors the phlegmatic. And now I'm thinking of replacing it by a new motto, which is discreteness is the better part of value. But anyway, and I can see that the fact that this is celebrating my 75th birthday is also a consequence of discreteness. Anyway, I want to say before I subject you to my paper, I just want to say thank you very much, dear friends, for coming here and for helping to celebrate this. It really means an enormous amount to me. And I'm grateful to every one of you for coming and participating. And I'm especially grateful to Zaifu and Peter and all of the people, Alex and Nagori, and all of the people who put together this wonderful program. So anyway, I'm going to give you a talk today which builds on my work with JJ Meng, who's here with us today, and which also is an example of discreteness. But it's also odd for me because it's one of the very few non-game theoretic papers that I've written. But anyway, I'll try to tell you quickly what it does. I should say that an important contribution, aside from my co-author Laura Blow, was also made by my Oxford colleague Ian Crawford, who's not related to me as far as any more than he is related to you. He was born in India, and my Crawford ancestors went to Jamestown, Virginia 400 years ago. So probably we're eighth cousins, and we're probably eighth cousins too. But anyway, it's basically an attempt. Oh, I'm sorry. I can now. I hope you can hear me better. It's basically an attempt to look non-parametrically at the conditions for preference-dependent preferences to rationalize behavior. And non-parametrics is something that was completely new to me. It's kind of a cult at Oxford. It's kind of a cult in the UK. But it's also an interesting cult because it enables you to think more seriously about the implications of structural assumptions that you make, particularly in behavioral models. And this is one of the leading behavioral models that are preference-dependent preferences, which were initially suggested, I think, by Kahneman and Tversky in their famous 79 econometric paper. So it was supported. The ERC insists on having their bling on everything, so I decided to put everybody's bling on it. In any case, here's what we do. basically, we look for nonparametric sufficient and almost necessary conditions for the existence of reference-dependent preferences that rationalize patterns of demand behavior that can't be rationalized by neoclassical preferences. The difference is reference-dependent preferences depend not only on levels of consumption, but also on a reference point, which is conformable to a consumption vector. So there's a difference between what you get and what you hope for that is also allowed to influence preferences. We're doing, in effect, a non-parametric version of Kőszegi and Rabin's famous 2006 QGA paper, which is the structural analysis that most people follow when they use reference-dependent models of consumer behavior. And I said the last thing already. So what do we show? First of all, we show that unless two things are true, the model is empirically empty in the sense that it can rationalize anything. And that's the usual instinctive reaction to behavioral models. They're too damn flexible. They basically destroy the parsimony of neoclassical models by allowing themselves too much flexibility. And the two things that have to be true for the model to actually be refutable are something that in the literature is called constant sensitivity, which I'll explain in a moment. And also, there has to be a model of the reference point. In other words, you can't just assume that there's a reference point that you can't observe, then you can rationalize anything. So there has to be a model of the reference point, and there has to be something called constant sensitivity, which is the element of discreteness in the analysis that I referred to before. So the bad news is, without these two strong assumptions, the model is irrefutable. The good news is that if you maintain these two assumptions, we can actually characterize the preferences and take a few steps along the road to figuring out what the preferences have to be. And in our characterization, we find that we're able to dispense with a couple of very strong assumptions that Kőszegi and Rabin made in their analysis. They assumed, first of all, that the preferences were additively separable across goods, which would be considered a silly assumption in ordinary neoclassical consumer theory. And I would argue that it's no less silly in the behavioral version of the theory. I know why they did it, because we went to the same graduate school, we were taught by the same brilliant, charismatic teacher, Bob Solow, that it was okay to make simplifying assumptions if they didn't distort anything. But we will show later on in the paper that assuming additive separability across goods is not only unjustified, it's empirically a very bad assumption. Second part of their assumptions, which also follows from the same thing, is that there are certain patterns, certain cross-regime constraints in marginal rates of substitution. So I'll show you later on exactly what those are. But there are knife-edge restrictions on marginal rates of substitution. For instance, they have to be the same in the gain-gain region as in the loss-loss region that we relax and that they maintain. So I'll go light on this, but we need an empirical illustration to show that these things matter. And we go back to the Farber cabdriver data set, the original one, not the new, much bigger one from the 2015 QGA paper, but the one that he was using in the 2000s, and the one that JJ and I used in our 2011 AER paper. And what we show is that you can use our model to estimate non-parametrically, and that the relaxation of the Kőszegi and Rabin assumptions really makes a huge difference empirically. But it's not a slam dunk for the behavioral model. What happens is for roughly half of the drivers in the data set, which is about 15, behavioral model does better. And for half, it's hard to say which one does better. Sometimes the neoclassical model does better. And in making these statements, we control for the flexibility of the model in a way that meets the usual objection to behavioral models, which is they're always more flexible. They always nest the neoclassical model. And because they're more flexible, they have to fit better. So the real question you want to ask is, okay, they're more flexible. Do they fit enough better to justify the extra flexibility? And time permitting, I will show you how we adapt a way that Zelton proposed to make that judgment. So I'm going to go light on the empirical background, but I do have to make a couple of points. We're talking about cab driver behavior. Why cab drivers? It's not that I care about cab drivers, except when I'm going from the airport to the city. Cab drivers are among the few people in modern economies who choose their own hours. So if you're interested in testing neoclassical consumer theory, you're going to be especially interested in cab drivers more than you are interested in assistant professors or business executives or other people who don't get to choose their own hours. So this literature started with the famous Kammerer, Babcock, Lowenstein, and Thaler QGA paper in 1997, in which they studied New York City cab drivers, an earlier set, not the set that we're going to be using, but they found a surprising thing. When most cab drivers have a good morning, which in Chicago, in neoclassical consumer theory, would suggest that they're going to work until midnight and maybe take a long weekend, they do something that really annoys Chicago economists, namely they go home early. And Kammerer et al. Suggested that this was due to something called income targeting. And income targeting is conformable to reference-dependent preferences, so I'll try to show you in a bit. But in any case, this was the first clear evidence that people were not behaving according to the neoclassical model. And I should say, I'm thinking about this as labor supply. Labor supply, neoclassical labor supply models are basically the same as consumer theory, where you have preferences over leisure and earnings to be spent on other goods. So that's why I'm switching back and forth between consumer theory and labor supply theory. So there's an empirical puzzle here, and that faces us with a choice. Do we just say that these drivers are crazy and send them to the sociologists or maybe the anthropologists? Or do we say, no, maybe they're rational, but they just have a larger domain of preferences? And the point of view of this paper, of course, is that they have a larger domain of preferences. And that also should make you a little bit worried, because if this guy can expand the domain of preferences just because people are irrational in a smaller domain of preferences, what's going to stop him? And there is a natural stopping point here, because the theory of reference dependence says you don't just care about levels, you care about levels and changes relative to a reference point. But that doesn't give you a license to keep expanding the domain of preferences when the model doesn't work. If you agree to stop there, you have a richer set of models, but it's still, contained in a small box that it can't escape from. So anyway, I should say personally, I was in the cab with them when they got the idea to do this. But it was pre-behavioral Vince that was in the cab. And I just thought they were totally out of their mind. Why would anybody want to do this? And I was smart enough to keep my mouth shut. If I had opened my mouth, maybe I would have become a co-author. But anyway, I was there in 1996, and it seemed insane then. And then I figured out why they were doing it only amazingly recently. I'm too ashamed to admit how recently. But anyway, so this stuff I've already said. Basically, what they're proposing is a reference-dependent model in which you care about levels and changes. Changes are necessarily measured relative to a reference point. They were casual about where the reference points come from. in their data analysis. But they did show that there was a sort of robust negative elasticity of labor supply in their sample. And after that, Farber came along and working with new samples of New York City cab drivers basically tried to show that the neoclassical model was actually better. And we did some things that I disagree with, and which we explain why they're wrong in the paper, but I won't explain them here because, you know, he's not here. But anyway, it's probably not important to know for this talk. So, but here's his perspective at the bottom of the slide. Basically, if you have a good morning, going home early is irrational from the point of view of the neoclassical model, because you're giving up opportunities to make more and more money on a day when making money is especially easy. So is it insane or not? Okay, I have to tell you a little bit about what Kőszegi and Rabin did to understand our analysis, because our analysis is the non-parametric analog of what they did. So the first thing is you have two different components of utility. One is ordinary consumption utility, what you're used to. The other is what's called gain loss utility in their analysis. And those two things are additively separable. Without that, I don't think you could really do anything. Conceptually, they are additively separable. So it's not, I think, a bad assumption to make. In any case, we maintain that assumption and we don't test it. And they maintain that assumption and they didn't test it. They allow reference dependent for all goods. By contrast, Cameron et al. Allowed it only for earnings. And in our analysis, we actually find out that hours targeting is at least as important, probably more important than earnings targeting. And they closed their model, and this is the most important thing that they did, by setting reference points equal to their rational expectations of your next choice. So in other words, what you expect to happen is determined partly by a reference point that is your own expectation of what you're going to do next. So there's an inherently game theoretic aspect to this decision theoretic model, which is a common feature of behavioral decision theory anyway. But in any case, it's important that they close the model. Our results depend also on closing the model in the sense that the key thing that we need to assume about reference points is that they're perfectly predictable. Not that they're necessarily determined by rational expectations, but that you actually have a model of them. Without that, the theory is empirically empty. Okay, so second assumption is preferences have constant sensitivity. Well, this is what JJ and I did. And what we did is typical of the empirical literature. We assume that preferences have constant sensitivity. I'll show you a picture of what that means in a moment. And what it means in words is that if you're in the two-dimensional consumption space, basically you have four regions. One in which you have a gain both on the hours dimension and on the earnings dimension, one in which you have a loss in both, one in which you have a gain and a loss and a loss and a gain. And what constant sensitivity means is that your indifference map has to remain constant in each of those four regions. The level of utility in those four regions has to change, but the indifference map that ultimately determines what consumption bundle you choose has to be constant within each regime. So that's what I meant by saying there's an element of discreteness in this talk. And what it does is it turns out that it's crucial for the model to have refutable implications. So other than that, JJ and I, following Kőszegi and Rabin, assume that utility has gain loss utility determined by the good by good differences between realized and reference consumption utilities. And that's something that we have to think about. So why does this help to explain the behavior pattern that I mentioned? In this picture from our paper, which has linear indifference curves, because at that time I couldn't figure out how to make Word draw curves. But the linearity is not otherwise significant. So there's 2 days depicted in this picture, a good day and a bad day. And the horizontal axis is leisure and the vertical axis is earnings. On a good day, there's a good trade-off between earnings and leisure. And you, in effect, start down at the right-hand corner and go up above the upper budget line. And you stop when you hit the optimum. And in JJ's and my estimates, drivers tend to stop at the second target that they reach on a given day. Remember that there's both an earnings target and an hours target. And so you can see that here on a good day, you blast through the earnings target first, and then you hit the hours target, and you stop there. By contrast, on a bad day, you blast through the hours target first, hit the earnings target, and stop there. So what are the elasticities of labor supply in those 2 cases? In the first case, you're stopping at the hours target independent of the wage, so your elasticity is 0. In the second case, you're stopping at the earnings target and your elasticity is -1. So very roughly speaking, on average, your elasticity is -1/2. And there's no presumption that the individual is irrational here. They're income targeting, they're rational in a larger space. So in other words, criticizing this from the neoclassical point of view is like saying, Alex likes apples and oranges. We know that only apples are utility relevant. Why is he wasting his money on oranges? So in other words, doing something because you care about changes is not irrational. It just means you have a larger space, at least from the point of view of this model. So let me move ahead. How much time do I have? Half an hour, okay. We're going to be okay, but let me move ahead to the substance. First of all, here are the knife edge market rate of substitution restrictions that I criticized Kőszegi and Rabin and implicitly JJ and me for making. And you can see that they are knife edge restrictions, and there's no particular reason to make them except that they follow from the simplification of the specification that Kőszegi and Rabin adopted, not for substantive, but for expository purposes. So there are also, of course, the usual functional form assumptions from labor economics, which we used to get the paper into the AER, whose editor at the time was a labor economist. And we certainly knew that we were going to get Farber as a referee. So we had to learn to act like labor economists and pretend to be labor economists. And therefore, we did everything that we thought we saw labor economists doing until the paper got accepted. And we went back to being ourselves again. So anyway, nonparametrics. So we're thinking about a single consumer and rationalization one person at a time. And what the reference dependent model does is it puts an R into the utility function. So Q is the consumption bundle, R is a reference point, which is conformable to a consumption bundle. And when I say reference point, I mean that to be synonymous with the targets. So if you're a driver, you may have an earnings target and an hours target for a given day. And also you choose earnings and hours on a given day. So the question is, what does it take for a utility function that depends both on Q and R to rationalize behavior? Now, in the model, Q is chosen, R is exogenous from the point of view of the driver. So it's basically an exogenous parameter that shifts preferences. And that's going to be important. And this nests all of the usual cases in the behavioral literature, so I will just skip ahead and go with that. Bunch of notation here, which is better explained when it becomes important. And constant sensitivity in these pictures, you can see what I meant when I said the math has to be the same when the when you're in a given, what we call a gain loss regime, the indifference map has to stay constant within that regime. So this is what Tversky and Kahneman calls sign dependence. And the way to think about it, and this took me a year, is the maps for the 4 different regimes are always there. It's just that an observation comes with a reference point that turns on one of the maps depending on which gain loss regime it puts you in. So think of them all as being always there. You need the whole maps for a rationalization because it's possible to have a reference point that makes any particular point in any one of these 4 gain loss regimes. So also notice that the level of utility does vary within gain loss regimes, even though the indifference map stays the same. Finally, it's the indifference map, not the level, that determines your optimal choice if you happen to be in a particular gain loss regime. So let's talk briefly about the neoclassical theory that this generalizes. And the key thing here is that there's a characterization of when utility maximization over levels can rationalize a given pattern of choices in consumer theory. So this stuff is all specific to consumer theory. Now let's focus on neoclassical consumer theory, which is about preferences over levels. There's a necessary and sufficient characterization in the neoclassical case that says, if and only if the generalized axiom of real preference is satisfied, can you rationalize the behavior? What does the generalized axiom of real preference mean? Think of a simple case where you have 2 budget sets and 2 choices. And in each budget set, you could have afforded the other thing, but you didn't buy it, you bought what you did. That can't be consistent with utility maximization because the first choice you made reveals a preference of what you bought over the other thing. And the second choice reveals a preference over the other thing for the other thing over what you bought in the first case. So, and you might be thinking about ties. I can handle ties here, but I'm not going to handle ties. Ties are easy to handle, and they don't change that statement. So there is a necessary and sufficient condition here, and it goes with a theorem known as Apriat's theorem, which is best formalized in Variance 1982, a econometrica paper, but also in a wonderful paper by Dewar. Do not attempt to read Apriat's paper. Unless you're dead drunk and it's midnight or something, you won't understand it. In any case, that characterization is going to be important, but I don't have time to really go through it. We're going to generalize this characterization to work with reference-dependent preferences, but it's not going to perfectly generalize. It's going to be a little bit trickier, and there is no necessary and sufficient guard-like condition for reference-dependent preferences. So also important how Apriat rationalizes things. A couple of pictures here, which I will just blast through to get to the new part of the stuff. Here's a variant picture which shows that even if GARP is satisfied in the neoclassical case, there's not a unique utility function that rationalizes a given finite data set. So variant shows how to characterize the upper and lower bounds on where the indifference curve can go through a given point that you want. And that's also important for us. So reference-dependent rationalization, obviously we need rationality because nonparametric demand theory runs on rationality. We have rationality in a larger space, and that turns out to be all the rationality we need. On the other hand, why isn't this just an extension of neoclassical consumer theory results? And the reason is twofold. The reason is that when I buy levels, I'm also buying changes at no extra cost. And also, if I buy something in my budget set that moves me into a different gain loss regime. I'm changing my preferences, and that might be beneficial, even if it wasn't beneficial with fixed preferences. So it's not a straightforward extension of ordinary consumer theory. It requires that we address a couple of different issues, the ones that I just mentioned. So two key things, as I said before. The key thing that determines whether or not you can rationalize are twofold. One, you need constant sensitivity. Two, you need modelable reference points. And the first theorems in the paper basically show that without both of those things, you're screwed. In other words, you can rationalize anything, and therefore the people who hate behavioral decision theory are right, unless those two assumptions are satisfied. And so the first proposition basically says, what if you have unmodelable reference points? And assume whatever else you want. And there, it's easy to see that you can rationalize anything. And what it means to have unmodelable reference points is that in effect, you can make them up as part of the rationalization. It's like the structural econometric practice of estimating things as latent variables. In effect, you let the likelihood make up what they are, which fits best. Here, how you do it, you hypothesize a reference point that coincides with an observation by observation. You hypothesize a reference point that coincides with the observation's assumption bundle. And then you create near Leontief preferences by making really steep or really shallow assumptions about the linear preferences that are active in each different gain loss regime. And in the finite data, you can always do that. And that's what we show in proposition 1. Proposition 2, suppose you have modelable reference points. So the objection in proposition 1 isn't active anymore, but you don't have constant sensitivity. Then the model only yields one restriction, which is now that you have modelable reference points, you can observe them in effect exactly. Suppose you have a subset of the data that has exactly the same reference point. Clearly, they have to satisfy GARP, where you can't rationalize. That's the only restriction. And the proof basically shows that if you construct preferences that rationalize anything in subsets that have exactly the same reference point, you can use an Afriat-like construction to rationalize everything else and knit the two things together. So it's not really interesting, but the punchline of those two things is, unless you have both modelable reference points and constant sensitivity, the model is empirically empty in the sense that it can rationalize everything. Now the question is, suppose you have those two things, what do preferences have to look like? And here we have a characterization that basically shows, in effect, what Kőszegi and Rabin did wrong. They made stronger assumptions than they needed, and it was those assumptions that implied additive separability across goods and the crazy cross-regime marginal rate substitution restrictions. And what we do is most easily summarized by looking at equation 6 here. And forget about the indicator functions, the capital G things. They just turn on the right part of the preferences for the gain loss regime that you're in. What the substance of 6 says is that preferences have to be the sum of two additively separable things. One is ordinary consumption utility, namely U of Q, and the other is gain loss utility a la Kőszegi and Rabin. And the substantive parts of the characterization of gain loss utility are twofold. First of all, it has to be additively separable across goods, as Kőszegi and Rabin assumed. And two, the reaction of the preferences to a change in consumption of good K, Q sub K, has to be exactly the same as the reaction to a change in the reference point R sub K. And that's also something that Kőszegi and Rabin assumed. And there are different preferences for gains and losses, as there usually are in reference-dependent theory. And the only thing that Kőszegi and Rabin did that's wrong is that they extended this structure for the gain loss utility, which is a necessary consequence of continuity of utility across gain loss regimes. I forgot to say that's the key assumption here. They made the same assumptions about consumption utility, but they didn't need to. And because you don't need to make the same assumptions about consumption utility, you can make the preferences that actually determine your choices, namely U of Q plus the Q parts of gain loss utility, anything you want. They don't have to be additively separable across goods. They don't have to satisfy any special restrictions on marginal rates of substitution. So our generalization basically says, what do you really need to have a viable set of preferences with constant sensitivity and with modelable reference points? And the answer is, you don't need as much as Kőszegi and Rabin assumed. And later on, of course, you're going to want to see us test that. And what we show is that for almost all drivers, the extra assumptions that Kőszegi and Rabin made that they didn't need, and that JJ and I made, blindly following Kőszegi and Rabin, and that Farber made, and everybody else in this whole literature made. Nobody has ever relaxed these assumptions before that I'm aware of. And I don't just mean labor supply, I mean finance, housing demand, anything. Basically, they all get rejected. Okay, so I won't do this. What happens if you have modelable reference points and constant sensitivity? Well, we characterize, I have 15 minutes, I believe. I think that'll do it. But we characterize the preferences, and then we show how to implement the characterization empirically, non-parametrically. And basically, the way it works is as follows. Well, actually, there are two propositions in the paper. Let me tell you what the propositions do. The proposition 4 basically gives you a general necessary and sufficient condition for rationalization. In this case, that's not implementable because it depends on an unspecified choice of the preferences that rationalize choice within each gain loss regime. And you need to make a special assumption about which way you're doing it. Remember the variant picture that I showed you, there are lots of ways to do it. Proposition 5 says, okay, it's ambiguous. Let's do it the way Afriat would have done it. And then it gives implementable sufficient conditions for rationalization, which are no longer necessary because we picked a particular way of rationalizing preferences within gain loss regimes. And it wasn't the only possible one. But there's a sense in which these things are asymptotically sufficient. If you have what I call rich data in the paper, then effectively, in the end, you'll get sufficient and almost necessary conditions. So let me instead take our time to show you how we actually do this. And basically what we need is to check two things. First, we need to construct a rationalization of the choices in the, we have a set of observations. We have observable reference points or modelable reference points. They allow us to sort the observations into bins, each of which corresponds to a particular gain loss regime. Gain, 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 loss, 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 gain. And then we take each of these things and we basically have to rationalize each choice within its gain loss regime, which we can do pretty much the way Afriat did. But we also have to check that it's not good to buy something that you can afford that's not in the home gain loss regime. And that's hard. And that's hard because it requires an estimate of the whole utility function, whereas ordinary non-parametric revealed preference stuff gets away with less than that. And Proposition 5 shows that we can still do that in a tractable way. And I won't abuse your hospitality by telling you exactly how we do it. but it's pretty clearly set out in the paper if you're interested, and I'm certainly here for the next few days to talk about it if anybody is genuinely curious. But in any case, what you have to do is two things. You have to rationalize within a regime and across regime. The characterization makes the within regime rationalizations a little bit tricky because there are actually constraints about utilities across regimes. And Proposition 5 tells us exactly how to do that. What you do is you set up a program that basically constructs a rationalization that works within regimes. And then you show that it can be extended to work across regimes. If the preferences satisfy loss aversion, the cross-regime constraints are guaranteed not to be binding. But we don't want to assume that. And if we don't assume that, then you actually have to check them. So that's what we do. Let me instead move ahead and look at the actual application to data and show you what's going on there. But here's a key picture. This, on panel A of figure 3 here, what you have is two observations that together violate GARP. So in the neoclassical case, they can't be rationalized. But they also happen to be in different gain-loss regimes. Q1 is in the gain regime, and Q2 is in the loss regime, so they can have different preferences. And what the panel shows is that if you just take what would have been the apriori preferences in those two cases, you can actually rationalize them in the sense that the preferences that you choose depend on which regime you're in such a way that the choice that you make in a given regime is optimal within that regime, and you also don't want to defect across regimes. So that's the meaning of that picture. And panel B just shows that it doesn't have to be the apriori preferences. It could have been a lot of other different things. So in any case, that's basically how the rationalization works. Now, this isn't guaranteed to work. You need conditions for this. And I think I was smart enough to give you a picture in panel A of figure 4 that shows what goes wrong when it does go wrong. Same situation as before. In other words, two observations that together violate GARP in the neoclassical case, and sorry, and they're in different gain-loss regimes, so the preferences can be different. But the apriori preferences don't actually give you a global rationalization of both of those things because they make you want to defect from your home gain-loss regime to another gain-loss regime that's within your budget. So in any case, it doesn't always work. As I said before, it always works when you have loss aversion. So let us move ahead and talk about, instead of talking more about the characterization, let's talk about what happens with Farber's cabdrivers. And we used Farber's cabdrivers because JJ and I used them, and we thought that there was one, we wanted a small data set. And it is a small data set because computationally it's very difficult to do this stuff in large data sets anyway. Plus, we also thought that there was some historical reason for using the same data over and over again because so many battles have been fought by neoclassical and behavioral folks on this same battlefield. So in any case, we just wanted to look back and see who really won this fight. And the answer is it was sort of a tie, but maybe the behavioral folks won a little bit more than the neoclassical folks. The other thing is, it's the custom in the labor literature to treat everybody as homogeneous. So there's in effect a reference to what's the word? Anyway, there's a representative agent culture in the labor literature, which JJ and I slavishly mimicked to get the paper into the AER. But really, drivers are different. And the culture of nonparametrics is everybody's different. You got to model them at the individual level. And maybe later on, you could find that you could group them together. For instance, you might find that half of your drivers are neoclassical. You can model them homogeneously, after your drivers are reference dependent in a particular way, you can model them. So in other words, you can have a latent class model. But what we did was basically just to do it driver by driver to see what was really going on. And that has some advantages and some disadvantages, as you'll see. So one key thing that's important is we had to treat the wage variable somewhat differently than it has been treated in the labor literature. Basically, because the standard treatment results in a given driver's budget sets all pivoting around not working at all, and therefore makes GARP trivially satisfied. And there's a case, although it's not an open and shut case, for treating waiting time as an exogenous shifter that gives GARP some bite. So we did that. And let's just go ahead and I've said most of that stuff. This is the recipe. I won't go through it because it's qualitatively the same as what I said before. Other stuff, model comparisons. So we use a variant of Zelton's proposal, of which the best thing to read is my co-author or my colleague Ian Crawford's paper with B&E, and I think the 2010 AER, which does neoclassical consumer theory this way. Zelton asks, in comparing models of different flexibility, what's a good model? More flexible models fit better. Do they fit enough better to justify the extra flexibility? And to answer that question, you have to define flexibility in some way. Udenberg and Lang and various other folks have been doing this in a number of ways, which they started doing before they knew about Zelton. I told them about Zelton, and I still don't think they completely do justice to Zelton. But anyway, they do it in different ways. We do it in a pretty simple way. Our view of what a good model is, a model is good if it fits the data and if it was very unlikely to fit random data. And you can implement that. There are some choices to be made in implementing that, some of which are arbitrary, but which seem pretty obvious in this particular application. And you should look at B&E and Crawford's paper if you want to see a coherent discussion of what the choices are. And that's the way we compare the models. And I'm going to use the term Zelton measure. And with reference to B&E and Crawford, we use the proximity-based variant of this, which measures closeness rather than saying all or nothing, whether something is an exact fit. So what do? First, we test additive separability across goods. And it flunks badly. And the way to see that it flunks badly, first for neoclassical models, is to look at what happens if you impose and relax additive separability across goods. Remembering that these are CDFs of something good, therefore being low is better. So the bottom panel shows that relaxing additive separability makes neoclassical models better. Not a big surprise. I mean, if somebody had accidentally started out doing consumer theory, imposing additive separability across goods, and then we did that empirically for 20 or 30 years, and somebody figured out how to relax it, it would be no big surprise that it improves the model. Second, what about reference-dependent models? Same thing. Look at the bottom panel, and you can see that almost unambiguously relaxing additive separability improves the fit of the model. Controlling for flexibility because we're using the Zelton measure. So obviously in the top panel, they have to fit better. The top panel is basically meaningless because it just says more flexible models fit better. You knew that. It's the bottom panel that's meaningful. So now we're going to forget about additive separability and just relax it. All the rest of the comparisons are about relaxing. What do we do here? And this is in the web appendix. which is why it has colors. Obviously, it would be meaningless without colors. And we're comparing a whole bunch of different reference point models. Expectation space, which is Kőszegi and Rabin's rational expectations view, and experience space. Expectation space are estimated the way JJ and I did by leaving one thing out. So if you wake up on a rainy Tuesday, you want to know what it's going to be like. It's like all the other rainy Tuesdays, excluding the one that you're waking up on. So basically what this shows, and these are proximities, so we want the Zelton measures. Basically what this shows is that for the most part, the red model wins. And the red model is expectation space conditional on day versus night. So I don't know if there's any particular significance to that. In any case, we think that the expectation space model that's unconditional, the black one, does almost as well. And we use that for simplicity in the rest of the comparisons. So next thing, what about different kinds of reference dependence? So remember, the labor literature all has earnings targeting, but not hours targeting. Kőszegi and Rabin and JJ and I have earnings and hours targeting, and nobody has hours targeting. So one interesting question is, which works better? And the answer is, here are the proximities. Let's look at the Zelton measures, and you can see that hours targeting mostly works better. So in other words, it's an empirical mistake from the nonparametric point of view for the literature to have focused obsessively on earnings targeting. And it's a weaker mistake to do what JJ and I did, which is to have both hours and earnings targeting. Adding earnings targeting to hours targeting almost doesn't pay its way in the Zelton language. Final thing is what happens if you do it driver by driver, comparing neoclassical and reference dependent models, relaxing additive separability across goods and focusing on the expectation space, or the other one, the unconditional models. And the bottom panel here basically shows that in the aggregate, the comparison is not a slam dunk for reference dependent models. Sometimes they're better, sometimes they're worse. And so what we do next is we look at it driver by driver. And here are the relevant pictures. I suggest to preserve your sanity till the end of the talk. You look at the left-hand ones and the Zelton measures, and you can see what's going on driver by driver here. The gray areas are bounds that we derive that I don't have time to explain. And you can see that it's, for some drivers, the neoclassical model is the heavy dark line, and the reference dependent model is the dotted lines. And sometimes the bounds are conclusive and sometimes not. And you can see that sometimes the reference dependent model does better. Sometimes the neoclassical model does better in the Zelton sense. What's really going on here? So what's happening is there are basically three kinds of data sets. There's one data set per driver that has a small number of observations. And then almost certainly the neoclassical model is going to fit perfectly. Because of possibly overfitting or possibly because the neoclassical model is right. You can't tell. The neoclassical model is less flexible, therefore it wins the Zelton measure for those things. The second kind of set of observations per driver, which has too many observations for us computationally to figure out how to fit the model exactly. And there we make an arbitrary assumption about the proximities that mean that the neoclassical and reference dependent model are tied. And therefore, again, the reference dependent model loses because it's more flexible. The middle case is cases where we can actually estimate something. And that middle case is summarized in the second to last paragraph here. And what you see here is that the reference dependent model does better for 5 drivers, and the neoclassical model does better for 3 drivers. And it's almost the same for experience-based reference points. So it's a tie. So the punchline is if you're serious about figuring out what these folks are actually doing, you're going to need a latent class model, and it's going to have to allow for reference dependence for at least some drivers, not necessarily all drivers. But for sure, you can't just live with the neoclassical model in this particular data set. So anyway, I've taken enough time. Thank you for your attention.
Okay, just one question. Anyone? Yeah, please.
Could you explain this with reference-dependent beliefs? So I'm thinking about you expect an average amount of revenue in a day, and if you had a good morning, then you're expecting a bad afternoon, and so it's something to go home.
So we actually, JJ and I do some of that, and there's a recent PER paper by Crawl and Toe. How do we? Okay. In any case, there's a recent paper by Crawl and Toe. So JJ and I's analysis is static, and we thought the set of models was rich enough so that it didn't make sense to try to do learning about reference points or implicitly beliefs about reference points. JJ has done some work on her own, I think, about beliefs in finance, which she can tell you about after the talk. The Crawl and Toe do a learning model, but they basically do what JJ and I did, but they add a learning component to beliefs about the reference point. And, it did well enough to show up that there was some learning and to get into the ER. And I think we probably were involved in the refereeing process. But to me, it's not as natural as having a simple static model of the reference point. So I think for experienced drivers, they sort of know what rainy Tuesdays are like. And therefore, I don't feel very guilty imposing a structure that's compatible with Kőszegi and Rabin's rational expectation society.
Okay, thank you very much. Can I suggest that everyone stand up? We give Vincent a huge applause.
Get used to this. I gave a talk at Tom Shelley's retirement party long ago. And he said something that Al echoed 10 years ago. Basically, he was surprised and delighted to have discovered that some people actually loved him. And Al said the same thing. Basically, he said in Exeter at this conference we were at together, if there's a large enough sample, you can find that there are some people who really, really like you. And we sort of do this theoretically, but it's wonderful to see it happen in real life. Anyway, thank you very much for coming, and thank you for your attention, and thank the speakers, especially and the organizers, for these incredible talks. So anyway.